Hello and welcome to Kashmatics. In this tutorial I'll show you how to find the area under a curve which has been defined using parametric equations. Now in order to follow this you'll need to be familiar with solving simple trig equations, integrating trig functions as well as using the reverse chain rule. So if you're rusty on any of these or haven't yet learnt them, then please go and watch those videos first. Otherwise grab yourselves a pen and some paper and let's get cracking. Before we start with curves defined parametrically, let's have a look at normal integration. If I wanted to work out this shaded area here, what I would do is I'd solve the equation f of x equals 0 to work out what a and b are. And those would be my limits for my integration. And then what I'd do is I'd integrate the function as normal, stick in the limits, and that would give me my area. Now if instead you have a curve defined parametrically, x will be a function of t and y will also be a function of t. Now the first step would be the same as before. What you need to do is you need to work out where it crosses the x-axis. Okay, so which value of t will make y 0. So you solve y equals 0 or g of t equals 0 and you'll get your two limits. And then what you do is you've got to use the chain rule to change the area formula. Normally a is equal to the integral of y dx. And what you do is you rewrite the dx as dx by dt multiplied by dt. So the dt's would cancel out, leaving you with just dx. Okay, so this here is equivalent to dx. So I can write down the area function as the integral of y dx by dt dt. And I'll show you how that works in the next three examples. Before we start this first example, let's remind ourselves of the area formula. So a equals the integral of y dx by dt dt. Okay, now the first thing I need to do is work out what my limits are. So I need to know when y is equal to 0. So 1 minus t squared equals 0, which means t squared is 1, t equals plus and minus 1. Okay, so that's nice and easy. That's what our limits are going to be. The other thing I need to know is what dx by dt is. So if x is equal to 2t, dx by dt is equal to 2. All right, and what I do now is I need to plug all of this information in to this integral over here. So a equals the integral of y. Now y is 1 minus t squared. Dx by dt, which is 2, multiplied by dt. So what I do now is expand these brackets to get the integral of 2 minus 2t squared dt. And now I can integrate it. And that would give me 2t take away 2t cubed over 3. Okay, and the limits, remember, are 1 and minus 1. Okay, so 1 and minus 1. So 2 times 1 is 2. Take away 2 times 1 cubed over 3, so that's 2/3. And then I put the lower limit in, and I'll get minus 2. Take away 2 times minus 1 cubed, so that'll end up being a plus 2/3. And if I expand the brackets again, I'll get 2 minus 2/3. Add 2, take away 2/3, so they cancel each other out, leaving me with just 4. Now this next example is trickier because it involves trig functions, and whenever you're dealing with trig functions you have to look really carefully at the domain of t when you're deciding what your limits are. So just like before, I need to solve y equals 0. So I've got sine 2t equals 0, which means 2t is the inverse sine of 0. And if I look at my sine curve, okay, now because the domain is between 0 and pi over 2, and I've got 2t, I can look between 0 and pi, so I can see that 2t is 0 and pi, which means t is 0 and pi over 2. So these here are my limits. Now along with that, I need to know what dx by dt is. I've got x equals sine t, so dx by dt will equal cos t. So I've got everything I need now, and what I can do now is I can actually plug it into my integration formula. So if you remember, a is equal to the integral of y dx by dt dt, which in our case is going to be the integral of y, which is sine 2t, dx by dt, which is cos t, dt. Now in order to integrate this, I need to use a double angle formula for sine 2t. So that would be 2 sine t cos t multiplied by cos t, which is the integral of 2 sine t cos square t dt. Now the reason why I've done that is because now I've got my integral in the form of the function times the derivative. Okay, so this is the function, okay, and this is a function squared, and this is the derivative. Okay, I'm talking about the sine t. What I need to do now is increase the power of the function, so that's going to be cos cubed t, divide by the new power of the function, which is 3, and then make my adjustments. Cos t becomes minus sine t, so I need to introduce a minus to get rid of the minus, and then I need a 2 as well. Okay, so there is my integral, and my limits are pi over 2 and 0. And all I need to do now is stick in those limits, and I've got my answer. Now looking at the cosine curve, and if we draw the cosine curve, we get this. Here's pi over 2. Okay, so the pi over 2 is there. So we can see that the cosine of pi over 2 is 0, and the cosine of 0, which is the other limit, is 1. Okay, so let's just plug those in. So the first one's easy, so minus 2 cos pi over 2 squared. Now we know the cos of pi over 2 is 0, so we get 0 for the first one. Take away minus 2 cos cubed 0. Now cos cubed 0 is going to be 1. Okay, so I'll get minus 2/3 for that. So overall, my area is 2/3. So like I said in the introduction, if you haven't done the reverse chain rule or you're a bit rusty with it, you are going to struggle with this. So that's the step you would have struggled with, getting from there to there. Okay, so I've got a video on the reverse chain rule, so go and watch that if you were struggling to understand those steps. And on to our final example. So with this one here, it's another trig question, so we've got to pay attention to the domain, and let's just start off by solving y equals 0. So I've got 1 minus 2 cos t equals 0, which means cos t is equal to a half. And if I use my cast diagram, okay, so cos is positive here and here. Now the inverse cos of a half is pi over 3, so that would be pi over 3, and that is pi over 3, which means t is equal to pi over 3 and 5 pi over 3. Okay, so those are my limits. I also need to know what dx by dt is. So if x is equal to t minus 2 sine t, then dx by dt would equal 1 minus 2 cos t. And let's put all of this into our integration formula. So y equals the integral of y dx by dt dt, which in our case is going to be y, which is 1 minus 2 cos t, multiplied by dx by dt, which is also 1 minus 2 cos t dt. And I'm just going to rewrite that as 1 minus 2 cos t squared dt. Now in order to integrate this, I'm going to have to expand the brackets and use some trig identities. So let's write it over here, because I'm going to need a fair bit of room for this. So I've got the integral of, now this becomes 1 minus 4 cos t plus 4 cos squared t dt. And if you remember from my videos on integrating trig functions, if you've got a cos squared t or a sine squared t, you use a double angle formula for cos 2t. So in this case, you've got cos 2t is equal to 2 cos squared t minus 1. Now because I want 4 cos squared t, let's just double everything. So I've got 2 cos 2t is equal to 4 cos squared t minus 2, which means 4 cos squared t is equal to 2 cos 2t plus 2. Okay, so instead of writing this, I'm going to write this. So let's rewrite the integral. So it becomes 1 minus 4 cos t plus all of this, which is 2 cos 2t plus 2. And if I tidy up a bit more, it becomes 3 minus 4 cos t plus 2 cos 2t dt. So now we can actually integrate this, and what we get is 3, which becomes 3x. 4 cos t becomes 4 sine t. In this case, it's minus 4 sine t. And this last term becomes 2 sine 2t over 2, which is just sine 2t. So plus sine 2t. And my limits are 5 pi over 3 and pi over 3. Now what you can do to make things a little bit easier for yourselves is you can work out the sine of 5 pi over 3 and pi over 3 separately over here. And because I need sine 2t, I do the same for double these angles. Okay, so the sine of pi over 3 is root 3 over 2, and the sine of 2 pi over 3 would be minus root 3 over 2, and the sine of 5 pi over 3 is also minus root 3 over 2, and the same for 10 pi over 3. That's also minus root 3 over 2. So let's plug all of these in to our limits and see what we get. So what I get is 3 times 5 pi over 3, which gives me 5 pi. Take away 4 times sine 5 pi over 3, which is minus root 3 over 2. Add sine of, now this is going to be 10 pi over 3, which is also minus root 3 over 2. So that's my first limit sorted. Now for my second limit, so this is going to be take away 3 times pi over 3, which is just pi. Take away 4 times sine pi over 3, which is just root 3 over 2, plus the sine of 2 pi over 3, which is minus root 3 over 2. Okay, so we just need to tidy all this up into a form which is nice and easy. Okay, so what I'm going to get, I'm going to get 5 pi take away pi, which is going to be 4 pi. I'm just going to tidy these up separately and just take my time with it. So this is going to be 4 root 3 over 2, which is 2 root 3, and it'll be positive. This one is going to be minus root 3 over 2. This one's going to be a positive 4 root 3 over 2, which is just 2 root 3. And this one is going to be a positive root 3 over 2, which simplifies to give me 4 pi plus 4 root 3. So that's the final answer. So that's parametric integration covered. Next time we'll go on to solving simple differential equations, but for now that's all there is. So thank you for listening and thank you for watching, and I'll see you next time. Goodbye for now.